Generally, the length of the bond between two atoms is approximately the sum of the covalent radii of the two atoms. Bond length is reported in picometers. In a bond between two identical atoms, half the bond distance is equal to the covalent radius. A bond between a given pair of atoms may vary between the different molecules. Therefore, the bond length increases in the following order. Triple bond, shorter than double bond and single bond. In previous section, we used Lewis structure of individual atoms to illustrate the bonding process. The following are steps in writing Lewis structure for more complex molecule. First, determine the central atom. For complex molecules or polyatomic ions, the least electronegative element is normally the central atom, except hydrogen. Terminal atoms are usually more electronegative atoms. Second step, determine the number of valence electrons associated with each atom. Combine them to determine the total number of valence electrons in the compound. For polyatomic cation or anion, remember to account the charge on the ion. For polyatomic anion, add 1 electron for each negative charge. For polyatomic cation, subtract 1 electron for each positive charge. Third step, draw the skeletal structure of the compound. Next, link the central atom to each of the surrounding atoms with a single covalent bond. Continue with step number 5. Calculate the number of non-bonding electrons. Subtract the number of electrons involved in bonding from the total valence electron from step 2. Next, step 6. Use the valence electron in pairs to fill the octet except hydrogen of the terminal atom. If there are just enough valence electrons so that every terminal atom has an octet electron except hydrogen, it means the Lewis structure is complete. Step 7. If there are extra valence electrons, then put them around the central atom. Last step. If there are not sufficient electrons available to complete the octet of the atoms, move lone pairs of the terminal atoms to form double or triple bond with the central atom. Convert a single bond to double bond if it is shortage of 2 electrons, or convert a single bond to triple bond if it is shortage of 4 electrons. Lewis structure provides a simple model for rationalizing the bonding in most known compounds. However, there are covalent molecules that fail to obey the octet rule. There are three general exceptions to the octet rule. First, incomplete octet. Second, expanded octet. Third, odd electron molecule. There are certain atoms of certain elements that can exist in stable compound forming bond with less than 8 valent electrons. When this occurs, the atom of the element within the molecule is said to contain an incomplete octet. Incomplete octet occur when a central atom has less than 8 electrons in its valence shell. Example, beryllium, boron, and aluminum do not achieve octet configuration even after sharing electron with other atoms. Example, in beryllium chloride. Beryllium surrounded by only 4 electrons. In boron trifluoride. Boron surrounded by only 6 electrons. In aluminum trichloride, aluminum surrounded by only 6 electrons. Expanded octet occur when a central atom has more than 8 electrons in its valence shell. When expanding the octet, the central atom uses the empty d orbital available at its valence level. Expanded octet is possible only from period 3 element onwards, due to the presence of empty d orbital that can accommodate the extra electrons. For example, in sulfur hexafluoride SF6, the sulfur atom forms 6 covalent bonds. Hence, it has 12 valent electrons due to the presence of empty d orbitals. There are a number of molecules whose total number of valent electrons is an odd number. It is not possible for all of the atoms in such a molecule to satisfy the octet rule. Odd electron molecules occur when a central atom from an odd number group, such as nitrogen, are located at group 15 and chlorine are located at group 17. Example, molecules such as nitrogen monoxide with an odd number of electrons, which is 5 electrons. There are a number of molecules whose total number of valent electrons is an odd number. It is not possible for all the atoms in such a molecule to satisfy the octet rule. Odd electron molecules occur when a central atom are from an odd number group, such as nitrogen, located at group 15, and chlorine are located at group 17. Example, molecules such as nitrogen monoxide with an odd number of electrons, which is 5 electrons.